Coming up on this episode of the IoT Inc. Business Show.
There's a large set of data that's going to be coming off of either machines or when you're building the parts that you're getting off the parts itself that creates that what we think of as a data structure for a digital twin. But we integrate that with applications and analytics to enhance the digital twin because the data itself is just the data. So how are you taking this information and creating more of what we think about advanced information associated with a digital twin?
The digital twin can be hierarchical, representing environments, systems, products, and even parts. When digitizing supply networks with digital twins, the network can be a digital twin of its systems, which can be digital twins of their assets, which can be digital twins of their parts, which themselves can be digital twins. Sound complicated? It doesn't need to be. Start at the level of the hierarchy that returns the most value and then proceed from there. In this episode of the IoT Business Show, I speak with Dr. Lane Warshaw and Aaron Parrott about the digital twin and its profound use in digital supply networks.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is Dr. Lane Warshaw and Aaron Parrott from Deloitte Consulting, who support the development and the deployment of IoT for digital supply networks. Lane focuses on data management, data warehousing, big data, and cloud, while Aaron develops analytic solutions to address his clients' most difficult business needs. Gentlemen, welcome to the show.
Thank you. Nice to be here. Very nice to be here.
First, let's define, what's a digital supply? Let's first define digital supply networks.
So, supply networks is really the entire supply network required to build a product, from multi-tiers of supply chain all the way through operations, through logistics and delivery to the customer. And when we think about digital supply networks, we're thinking about the digitization of that entire network to have more near-time information and real-time information around how your supply network is performing and adjustments and changes that you may need to make to more efficiently operate the supply network so that you can drive better results, deliver your product at a higher level of operational efficiency and basically with shorter amount of time. So it's trying to digitize that entire supply network that our clients have across building their products.
Now, I'm assuming that IoT is playing a big role in this. How have you layered on IoT, just at a high level? We don't have to dig too deeply into it, but I'm just wondering, where are the biggest effects that you've seen so far with IoT in this digital supply network?
So a lot of the initial focus that we've worked with our clients on has really been inside the 4 walls of the factory, developing solutions to help them better manage their factory operations. But we're now in conversations with our clients about thinking about applying IoT solutions back into their supply base and also utilizing this IoT information to give better and more near real-time information to the customers.
Yeah, no, that makes total sense. Now, does it stop after the product has been developed, and do you continue on, or is it really just the supply side and not the distribution side? We
look at the IoT all the way out through the distribution and even extending further into the life of the product in the field, leveraging information about how the machine is performing, when maintenance is due, and getting information from these fielded products to really understand where their opportunities are to provide services to their customer base around either maintenance, predictive failure, utilizing this information to better design or feedback into the design loop of the product to address issues that they're seeing in the market and out in the field.
Yeah, no, that makes sense. And it's kind of funny because, yeah, I mean, we're talking cradle to grave to a certain extent, right, for a product life cycle. But on the previous podcast, kind of this interesting notion of hereditary came in, because you're just saying it here where you take the information and you try to improve the product. And he kind of said, all right, well, the digital twin, it's from cradle to grave. And then you take that information when you develop the next version of it. So it's kind of like an offspring of it. Then you have, what you have from the digital twin. I thought that was kind of a clever way of looking at it. But it's kind of, it's just a different way of saying it. But I mean, what you're talking about here really is going to take us into the digital twin, but it is utilizing that digital twin in, pretty much through the entire process. Well, Lane, why don't you start by telling us a little bit about yourself and your background in IoT?
Yes, so I've been at Deloitte for roughly 9-10 years, and I started my career as a database researcher. Got a PhD at the University of Texas at Austin. And over the last 3 to 5 years, I've really ridden the wave of big data and IoT as we've seen our clients move from traditional data warehousing to things like the digital supply network, where we're trying to make supply networks always on, always available, and now you have a tremendous velocity, volume, and variance of data. And really, we're just seeing such a momentum and move to this big data concept. And that's how I've gotten involved as I've matured in my career, really working with manufacturers to help them enable in end-to-end IoT type of solutions and big data solutions.
And what would how do you look at it? Because I think you could look at it both ways. Do you see IoT as a subset of big data, or do you see big data as a subset of IoT?
I see it as a subset. I see IoT as the streaming, and of course I got an announcement in the background here while I'm talking, but hopefully it comes through. But I see IoT as the velocity component of the big data solution. And then what we really see, and what we see with the digital supply network, is we tie in the volume with respect to back-end systems and the variety of things you can get from like social networks and user behavior, and tie in algorithms such as cognitive to make it a complete big data solution. So I actually see big data as a bit larger, but it really is incomplete without IoT, because you really don't have that connection from the physical world back to the digital world without IoT.
No, and I tend to agree with you on that. I do see IoT as a subset of big data, in particular when we're going to get into this. I don't know if we'll get into this exactly, but when looking at the digital twin, it really is hammering out a big part of the data structure of this bigger big data view, right? And this is one component of it. But we'll get into that in a little bit. But I'm interested to see how to incorporate the digital twin. Then, if it is a subset, how you incorporate the digital twin into the bigger picture. But we'll hopefully get to that in just a couple moments. Aaron, why don't you introduce yourself and your background in IoT?
Right. Aaron Parrott. I've been with Deloitte for 10 years last week.
Oh, congratulations.
Prior to coming to Deloitte. Oh, thank you. Prior to coming to Deloitte, I spent 13 years in industry. I started as a manufacturing engineer on the floor, worked my way up to running operations before moving over into the consulting world. And I started in IoT, these types of solution sets, about 4 or 5 years ago, when our clients really started asking us to address their more complex issues around leveraging supply chain analytics to get better visibility. And over the course of the last 5 years, I've implemented several large-scale supply chain analytics solution sets. And over the past year, with the new technologies and capabilities that we see in the marketplace, clients are really starting to talk about, how do I leverage IoT to solve my business issues, or basically solve the same problems I've been experiencing for the last 20 years, but I'm looking for better results, and more sustainable results that I can drive my business with moving forward.
So, Aaron, looking at it more from this business perspective, same question: IoT a subset or a superset of big data?
I look at IoT as a subset of the super data because, as Lane talked about, there's a lot more information that we're integrating into the solution set beyond just IoT information. Right. It's a key piece of it, but I've integrated natural disaster information into better managing supply networks, how earthquakes are impacting your supply network today, and social media and feedback and information from your customers, and how you start to think about integrating those larger sets of data to better manage the business and drive better outcomes and results.
Yeah, my perspective, again, like I said, is the same. And in particular, one part, when we're talking about IoT, one way to look at it is an IoT product really creates incremental value by capturing data and transforming it into useful information. And the capturing side is sometimes limited, or the narrative is around sensors, where what you're bringing up here, Lane was bringing up into the variety side of the data format, but there's a whole lot of other data that's available beyond just the sensor data that can be applied to the problem. And whether that problem is supply chain management, whether that problem is digging a hole in the earth to extract our natural minerals faster, in all cases, this data does come in. And so it's interesting because when you look at it, start looking at the intersection between big data and IoT, I always think of these external systems, but in reality, perhaps, those external systems belong not so much on the IoT side of things, because they're not necessarily, although I guess some of them could be used in real time, maybe like weather. So maybe as I talk it through, it does make sense to do it. But again, I'm just sort of a little bit hung up. I've been thinking about it a little bit lately, just the relationship between big data, a big data strategy, and an IoT implementation. And one of the first questions that I always ask, right, is what's your data strategy? And so I don't know if either of you guys have any views on that, but this integration of IoT into big data, I think all three of us are agreeing that, it is a subset of big data. What are your high level thoughts on that? What are the challenges, or is it just another data record?
So let me take it through a couple different directions here. So think about a solution on a manufacturing floor that only is IoT based. What can you do with that? And you're trying to improve on your manufacturing process. Mm-hmm. Well, you could, see exceptions. You can see if the line stops. You can see, if it's too hot or too cold. You can do various things in that floor. So that's IoT at its best. And you can do what's called a complex event processing. And you can do a lot there. But if you don't integrate it across your factories, across your enterprise systems, how can I actually integrate it with my supply chain, have an always-on supply chain, which says I have a big machine that's down in the field, and I want to go rush an order onto a particular manufacturing factory floor to a particular location because that's a really expensive machine, and some of the big machines we deal with our clients, any downtime is really, really not acceptable. So how do we rush it down? So in order to do that, it involves connecting it with the backbone of an enterprise. And that also will involve a data management strategy where your products and customers and locations and shipments and all that agree. And it's really that coming together is what companies come to us for. And it's because we try to solve those big end-to-end process problems. And so I see it as inextricably linked. And that's, my background was in data management. That's what pulled me into this area. This is a really new and exciting way to do enterprise data management that doesn't involve us solving the world's data management problems before we get going. The new exponential technologies that we have allow us to pilot and test and get value much more quickly and rapidly over time, and connect things much quicker, but still continue to evolve our data management solution over time to get value. While it may be difficult to do an entire product master, we can do it in a smaller subset and accelerate and get really, really good value in an area while we connect it to a digital twin and continue to look at how that product exists from cradle to grave. So it's a pretty exciting area, and I think I wholeheartedly agree with that. And as you can tell, I could talk for a long time on this. So I do think it's exciting.
Yeah, no, it is exciting. Aaron, do you have any thoughts beyond those?
Just very quickly, I think Lane hit on this, and what we're seeing our clients more focused on is less around a large or big data strategy and sinking a lot of money into how do I integrate and get all my data into one location and have it so I can figure out what I can do with it. It's more of we're working down with our clients of what is the set of data that you need to solve this specific business issue, and then getting that data set and integrating it into at least somewhat of a strategy of what we think it will be longer term of what your data management will be, but doing it in much smaller kind of segments of strategies where you're getting value every time you're solving a business issue while you're ultimately solving for a large data management strategy. But that's not ultimately the focus of what the business problem we're trying to address. We're more focused on how to address a business issue, not creating a big data management strategy.
Yeah, and I think Lane kind of said it in a slightly different way when he was saying a smaller project you focus. And I think what you guys are saying is there is a bigger data management strategy, and but you can't boil the ocean, you can't solve everything. So what's really great about IoT is that you can get that focused data on a product, on a machine, if that's what it is, or on this part of the supply chain. But you have to still have this flexibility, right, to be able to incorporate that and to grow the entire data management strategy as you add these digital twins, whatever they represent. We are going to get to digital twins, but as you add them, right, you still need to have that flexibility. And that's interesting. And I think what the takeaway here is for everyone listening is that it's highly integrated. However, you have to look at, and we're going to get into the digital twin because how you integrate it, I'm assuming it's going to be related to what we're going to be talking about now, but is on the digital twin. So, Lane, why don't you give your definition, and I'm going to ask Aaron the same thing, but we're just going to start off pretty simple or pretty difficult, depends. But what is your definition of a digital twin?
So I say a digital twin is modeling a physical asset in order to provide a digital copy of that asset and monitor that asset over the life cycle of that asset in order to see how it performs from cradle to grave. And what we're looking for is a digital twin is an application that's looking for variances from expectations. So it's more than a CAD drawing, and it's better than just a graphical design because it's a live measure on how this physical asset's performing, connected with a digital system over time. Probably a little more words than you would expect, but that's how I see it.
No. Okay. And Aaron, what about yourself?
I define the digital twin very simplistically as a virtual representation of the physical world. And that can be both in process and product.
In process and product, yeah. And it's interesting because, there is a debate whether there is one digital twin, there's many digital twins, but really it's hierarchical, at least in my view. So if we're going to use the example of the supply chain, or a part of it anyway, the manufacturing part of it, then you can have it at you can have a digital twin at a factory level. You can then go down a level and it could consist of digital twins at the system level, and the systems can consist of digital twins at the machine level, right, that are actually doing the manufacturing. And then you can even go down, they could consist of digital twins at the part level, right? Does that make sense to you guys? I mean, so it's kind of a hierarchical.
It absolutely does. And then you think about, you can build it back up. Now I can take the hierarchical of a product or part digital twin that's going through the process and combine all the parts together that I have a virtual representation of to create the digital twin of the product.
And one of the things that we debated is a process, can it actually be a digital twin? Can the process of manufacturing a more complicated product, or actually in some of the works we do, more complicated component, is that actually a digital twin? And we concluded in some cases, yes, that actually could be. because the systems in the physical world all tie together to make that product, and monitoring and creating a virtual copy of that is extremely valuable.
No, I absolutely agree. I do think a system, I do think a process. And again, these don't have to be physical processes either, right? We could have process engineering. So whether we're making gas or oil or something along those lines, it can be biological, I suppose, right? So it's not really, even limited. I don't think if we expand kind of the definition out a little bit, it's not necessarily limited even to physics, right? It could be, specifically when we get down to our models, which we're going to chat about in a moment. It can be economic models, that are part of this, that are part of the digital twin, too. Does that make sense, guys?
Yeah, especially in the what we call the chemicals and industrial products, where it isn't a physical. That is something that we do deal with quite a bit.
So let's okay. So we have the. Aaron's is pretty high level. We've got the digital representation of the physical. All right, and then so let's dig down a little bit. It can be hierarchical. It consists of data, right? We're all, I think, nodding our head there because we were talking about the overall data management strategy, and it consists of models. Okay, so these models then there's going to be a whole lot of different models depending on what it is that you're modeling. But are you guys nodding your head? It's hard to see, obviously. So we've got data, we've got models. Anything else that's missing in there?
So I can tell you how we thought of it. In that, Aaron, please chime in here. So the way I think of the architecture and the components is we're bringing in data from third parties, actual sensors itself, and we're processing this on the edge, and we're bringing it into that has some level of just traditional IoT, but then we're pulling that into an integration layer that allows to do cognitive AI, visualization, BAM, and other kinds of models. And we're putting an application on top of that with that has all these capabilities that does modeling. It could be any one of these kind of models. It could be simple down to more complicated AI routines. And these, what it really depends on what are we trying to look for? What kind of anomalies are we trying to look for?
Right.
That the measure to improve our business process or improve our product. And it's this set of capabilities that comes together that really forms a digital twin.
Yeah. And I guess my question back to you then is, and you kind of said the word, I certainly have an opinion on this, but is the application part of the digital twin or is it separate from the digital twin? And this is going to be any code that you're necessarily going to be writing.
In my view, I think that is the digital twin. I think it is an application. So my view is it's an application that brings in all these capabilities that we generally see in an IoT and big data solution. And when we see it, that's kind of how we write this. That we have this base of set of components that we can pull together. And the digital twin, it's monitoring things in real time and using these capabilities that come up to see, did we get a large variation? We usually run our supply chain and our manufacturing floor at a certain rate. Do we get a huge variation, and why? Did we connect it with weather and we're expecting to see a variation and we didn't? Do we have a normal seasonal change and we're not seeing the ordering pattern we expected? Do we see warranty? Do we see warranty and quality submissions to us for unusually on a component? Why is that? Is it because it's running too hot in a certain area, or what's the use? What's the reason for that? And those applications are built into the analytic models, built into the digital twin.
Built into the analytic models. Expand on that, because that's somewhat confusing for me.
So, again, I see the analytic models themselves as part of that application. And that's what we're defining when we're making a digital twin. It could be, a machine learning algorithm that is running, in the cloud. It's continually improving and monitoring signals as it's coming in. And I view that as a component of the digital twin. And it could be self-learning if it's machine learning enabled, which is, a strong push for where we're looking today.
Yeah, maybe it's like a nomenclature thing, because I agree on the cognitive side of things. I mean, that is one of the types of models that may be the best solution for that particular data set and what you're trying to do with it. Aaron, do you have anything to add on the application? Because I kind of tend to think it's a little bit separate, because you're able to take that digital twin, which is the data and the models, and then plop it into different applications, whether it's a simulation, whether it's a real-time application. But I can see how it can go both ways. So I don't think there's a right answer in this, because really what it comes down to is looking at the data structure of the digital twin, and does it have a method associated with it? Is there code associated with it? And I think there's pros and cons. But Aaron, I'd like to get your view on this.
So I kind of look at this the same way that Lane does, because I agree with you. There's a large set of data that's going to be coming off of either machines or when you're building the parts that you're getting off the parts itself that creates that what we think of as a data structure for a digital twin. But we integrate that with applications and analytics to enhance the digital twin because the data itself is just the data. So how are you taking this information and creating more of what we think about advanced information associated with a digital twin? I may see an RPM revving of a CNC machine that, although in itself is just a piece of information as part of the digital twin, but when I apply analytics and the application capabilities, that actually tells me there's a red flag associated with this. I should not have expected to see that kind of performance on that machine building this part at this moment in time, and we have an potential issue with this part itself. So I think of taking the digital twin and the data set of information and bringing that next level of value to it to provide insights and information that provides another layer of information for this specific digital twin.
That makes sense.
No, Bruce, I might add though that it could be the immaturity of the area, because as this grows and it seems to be things that could be packaged up in the regular patterns, I fully expect to see vendors offering more and more digital twin packages on specific problems within the industries. And we're already seeing some of our clients are looking at some of the big vendors that are very active in the game. Of course, they partner with us as well to try to componentize this and sell it as applications. But I would see that they'll continue to be expanded, and that goes back to the definition of view that I would see.
Yeah, because and that's kind of where I was going with this, but since you brought it up, I'll expand a little bit. Or let's expand the thinking a little bit. But I think digital twin, the concept of digital twin, and everyone's been listening to this mini-series knows that I personally feel it is the most important technology in IoT, because this is the nebulous, this is where the value is created, the genesis of the value. However, it is very early days. And what happens in early days are a whole bunch of different definitions, and eventually there's a standardization. And I'm thinking just a little bit ahead, on this definition, just to try to push this narrative forward within the industry. If we all agree that there will be at one point a standardization, because, I'm going to next ask you about how do we actually implement it and get it into our IoT products, systems, environments. I believe that standardization is the logical next step. Then the question is, if you are standardizing, let's say it's a digital twin for a CNC machine, I think that was brought up earlier, then it makes sense to, here's all the data, so I can now port this to a different platform. I can port it to a different analytics package, because that's really what we're talking about, either an application within an IoT product, system environment, or an analytics application. So I see, we need the data. Probably we want, and especially if they're cognitive models, we're going to carry those models along, the analytics models along with them. Then the question is, do we carry around the code, to actually exercise or execute those digital twins? And again, I'm not necessarily I think there's a right or wrong answer right now, but I just want to explore this with you guys. So if we were to move to standardization of a digital twin, what would be included? Do you still think the application would be included in there?
I do think there would be a couple of different layers that will be standardized. I think you touched on it at first. I think just the mere sensors and connecting and what a sensor can do in different environments has still got a lot of standardization. Our most recent projects, we had to bring in some of the sensor vendor, and we had to work hand in hand just to improve their sensors and how it would work in a live setting. And, as things mature, the readings we're getting and what we had to do. We had different readings in the manufacturing floor versus out on the lot. We had to deal with that, what the different readings are there. I think things like this it's like a prerequisite standard. What actually can we measure? And then what kind of complex event processing can we do? Can we measure heat, position, time, GPS coordinates and things like that? So there are some standards out there. And again, I'm not a hardware expert, so I can't name them, but there's some standards. I would bet there'll be more and more, especially as you get to like liquids and things like that and how you manage that. And as the chips keep on going down for RFID and things like that. So that's one set of standards. And then we're also seeing standards actually pretty rapidly on the other side, which is on the big data and analytics. I think, the on-premise distributions of like Cloudera and Hortonworks, they're really driving standardization of the open source big data platforms. And then Microsoft, Google, and AWS and cloud services are really driving some standardization too. And there's a whole bunch of others, and I don't want to leave any of them out, but GT Nexus and others. They're driving standardization of the analytics tool sets, and I think that's going to continue to push. Then on the third layer, I see standardization in cognitive too. So we see cognitive platforms as well. So I think every layer is right now for some sort of standardization that will need to be pulled together for us to, really have a good standard toolkit for a digital twin.
Yeah, you're right. You're right. There are a lot of different components that have to be taken into consideration. Aaron, anything to add to that?
Yeah, just briefly on that, I agree. I think that we're going to see more of the standardization across the different layers of the digital twin, and even including the set of analytics. Now, I always think that people will be looking to push the envelope, push it to the next level of analytics and capabilities that will be on the standardization. But I think there's going to come a point in time with certain set of predictive maintenance and some of the digital twins that we see going first, where a lot of it's going to be very much these are the standard sets of information, data, analytics that what the industry sees as kind of the standard set for in these certain areas. And then there'll always be companies that'll be pushing the limits to say we can go beyond that and provide above and beyond what you look at as a standard digital twin, and here's additional value that it can provide. Do both of you, Lane and Aaron, agree that there is, I guess, a need in the first place to standardize the digital twin, or would it be kind of sucked up into the big data, a la, how we started the conversation earlier? I believe there needs to be a definition going forward of the digital twin. You've seen enough, and obviously you've done a lot of research in the marketplace where there is how people think about the digital twin is not anywhere near standardized, and I think that's going to be the first thing that really defines the big data going forward requirements is what does a digital twin really mean, and how do we look at the digital twin in also even across different types of manufacturing and what that really means and how that changes when you think about a process versus discrete, consumer products versus highly engineered type of products. I think you're going to start to see that more being defined across the marketplace that will drive more of the big data requirements to support it.
Yeah. Elaine, do you agree?
I do, and a thought occurred to me that, as we're having this conversation, that if you look at like safety and quality, I really think that the standardization there, for example, TREAD, we deal with the TREAD Act with automobiles. If you had a standard definition of quality in automobiles and a digital twin definition, that would go from a differentiator to just a mandatory requirement of how you produce a vehicle. And I think that would be a wonderful thing for the market. And I think there's probably a number of things like that the more we standardize, there could be a couple of categories of digital twins, but some could be just making sure that we're meeting the specifications to what we need for a safely build, reliable, mass transportation product. And as we do like more automated driving and things like that, so I think it would become more and more important that we can rely on these kind of testing systems.
Yeah, and I agree. And I'm just teeing off, what you were saying earlier, Lane, in the sense that we're not dealing just with straight analytic data and models. And so I think, it has to go a little bit beyond just using what's out there now. And I like that example. I like the example of requiring a digital twin for certain types of safety applications, because just think about the value that's there, right? So.
Yeah, it'd be tremendous. Now we're very far. I mean, we're having a podcast.
Yeah, I know, and we're struggling there.
So we're a bit away.
Right.
So we got a bit of ways, but I think there's a lot of value if we can get there.
Yeah, no, and that's kind of our job, right? I mean, we're just trying to push this a little bit further, and this is kind of how it's done. But what?
And one last point on that. When you think about aerospace and defense, is probably one of the first earlier adapters of requiring serialization of certain sets of their parts that was really long before we even thought about that, the initial step towards a digital twin of what an airplane is.
What do you mean?
So any given part, for the major components of an airplane, you have to have the serialization of those parts and where those parts were made, and you have to have a certain set of information on each of those set of parts.
Right.
So if there's ever an accident, they can very quickly go back to the records and know exactly what parts were put on that machine, on that airplane, and start to do a backwards investigation, not only into what exactly happened in a crash, but also any of the components that were on that very specific airplane. That really started years ago, the requirements for this digital twin.
Yeah, and if you think, just using that example, if you think about how aircrafts are moving more and more, fly-by wire, I guess it is, or I don't know, I get that confused. It's not actually pulley, but you know what I mean, like fly-by data versus fly-by mechanical system. Then when there is a situation, so to speak, that you need to investigate, then the software side of things, componentized, that's probably not the right word, but categorized, at that level, the software at that level makes a lot of sense, which is where the digital twin can, play a big part. But all right, well, I mean, I think we're all in agreement there. But let's shift a little bit into the hands-on of actually how we make a digital twin. So who wants to take a stab at this? But how do you create a digital twin? And then in particular, how do you integrate it into the product or into the process that we've been talking about? Maybe Lane, you could take a first crack at it.
I would say I was going to, but I thought what would be interesting is the way we think about a digital twin is it always starts with the business problem.
All right.
That's just, how we just generally go to market. And Aaron, I thought it'd be really interesting if, before I could dive into the sensors and more like that you talk about, what's the process we determine where something is high value to apply it to.
Right. So what we do with our clients is really, and what approach that we take is trying to look at the factory, specifically focusing, if you think about the factory floor or even supply chain. What is the significant business issue that you're trying to address? What is the biggest problems or issues that you have, and where is the most value that you have from addressing these issues? So we've done this with several clients where we've more focused on the factory floor right now, was where we're seeing digital twins being created right now, is really walking the factory floor and identifying those specific issues that they're experiencing, and then discussing what is a way through an IoT solution that we can really address the business issue that they're facing. And from that, we create a business case around this and what we think the value is. And also you have to have a perspective of, well, how much is this really going to cost to implement? And is there a business case that says that it's worth addressing through an IoT solution? And so that's how we've really done this, and how I've done this at a very specific client where we've implemented an IoT solution on their factory floor that they're currently leveraging, and we're now expanding that solution to the other part of their factory. But that's how we look at addressing, how we think about coming up with an IoT solution, and then what is the sensors that we need? What is the infrastructure that we need to support it, both from a technology standpoint, analytics, visualization capabilities, to develop a IoT solution for the client? And I'll let Lane talk a little bit more about the technical aspects of integrating that together.
Yeah, but before Lane goes, yeah, you guys schooled me on my show. I mean, this is the IoT Business Show, and so you're 100% correct that the first step is obviously identifying where the value is. How you can add value, what is the outcome that you're trying to achieve, where do you fit in, and it is top down, right? What's the value? What's the information I need? What's the data I need? And so, by the way, now we get into our digital twins, in my view. So that's the data and the models that we need, and then the technology falls out of there. So, Lane, does that make sense? And you want to take it from there?
Yeah, I mean, exactly. So, I mean, and it's absolutely how we go to market. And the reality is, because it's not standard, it's not, a straightforward solution. So you don't want to do it unless there's a lot of value. You wouldn't want to do it for a component that doesn't either have a tremendous volume that drives your business or tremendous, margin that drives your business. So, I mean, we usually start, looking at that. How vital is this?
Now, when you say it and this, are you referring to what you are building the digital twin for? Okay. All right. Yeah. So first identifying, do you do it the factory, at a macro level where it's a black box, you've got raw materials going in and refined materials going out, or do you go at the system level, or do you go at the product level, or do you go at the component level, right? And so that's kind of what you're talking about?
Yep. And so then when we look at the layers, there's actually a pretty standard template, and we've kind of touched it, but I'll kind of hit on it now. But the very first thing is what signals do we want to create? So we identify initial issue. What signals do we want to create, and what data do we need to make this happen? So that's all about looking at the sensors, but it's not just the sensors. What data do we need to tie this together? Is it a full supply chain solution? Are we going to need suppliers? Are we going to need distributors? Are we going to need customers? So that's looking at what data needs to be created and what needs to be pulled together, and then how do we need to communicate it? So we actually spent quite a bit of time just on that alone. And just
what do you mean to communicating it, Bart? What does that mean?
A big issue, and I think we've also touched on this, is how do we get it off of the device and off of the sensor into something that's in a central aggregated layer? We've often pulled it out through network, and you always need some kind of data and communication interfaces. But do we push it right up to a cloud, or do we keep it and using edge processing because it's really high volume and keep it behind the factory and figure out, what's the volume, what kind of bandwidth we're going to need, and do we need to process it before we send it centrally, or can we keep it local? And so, when we're looking at that crate, we're looking at that volume that we need to process, and how big it is and what kind of networks we need. And what we generally see is a pretty consistent pattern that, wherever we're doing this, we're going to want to have some sort of edge processor that filters out the noise, does what's called complex event processing right there, that, closest to where those sensors are, and aggregate together before it goes to some layer. And that's helping just traditional IoT, what's important, what's not. And then some of the other data can be just, archived and sent at other times for use for later analytics, but doesn't need to be streamed in real time. And this will allow you to right-size your communication network. And one of the first things that we often saw in the early days of this is that every time you get a signal, you just want to send it over the network. That's hard to support. And then the alternative, just archiving everything, doesn't make it real time. So we're really working on that communication interface. What do we need to send? What do we really need to monitor in real time? What we don't. Once we get through those processes, we're really going to look at what we need to aggregate together and what's the data models we need, and what that process, the data model depends on the process and what data we're bringing in from various different systems. At that point, we might pull in the internal systems from that enterprise. Right. It's ERP systems, it's MES systems, other things like that we see. We might pull in third-party data from dealers or whatnot to analyze. And so that's in that aggregation level. And this is where the big data platforms come in. You generally see some sort of Hadoop layer, and we're seeing a heavy push to cloud for a number of reasons. One, sensor data as it's coming off of something in the field it's easier to get a sensor data through the security network of cloud to cloud than it is to bring it internally. And so usually bringing everything to the cloud is a good pattern that we're seeing more and more in this world. And that's pretty consistent across our clients in this digital twin world.
And to be clear, this is after you've done the edge processing, correct?
Correct.
Okay.
After the edge processing.
Okay.
And we're seeing it, a number of reasons they do this. Security-wise, cloud has its own challenges, but when you're pulling sensors off the edge, sometimes those are already in the public cloud. And so you can bring it from the public cloud to another public cloud very easily. And scalably if you use a cloud. And so we tend to see that. Now we also see the reverse, where it's all done in a private cloud, and we're pushing it out to a public cloud, and that's just more a cost equation. It's just simpler to go, scale and try to do it across large volumes of data in a cloud network, but certainly in at least a big data infrastructure at that point.
So what you're saying, sorry, go ahead.
And then the final piece is there's both the visualization and analytics that we talked about. So the data is aggregated in some sort of what we would call lambda architecture, real-time data and static data is coming in and being combined. And then we have the visualization and analytic models on top of that. And usually have a set of technologies that can, run those models and run those visualizations. And in this world, I think visualization is extremely important. It's good to see an exception, but a lot of times you can't see that exception. A really good, high-quality visualization will allow an operator to see an exception that you would never see or be able to monitor in a model and just pick it out. So visualization is very important in this area as well.
Analytics, in a sense, right? Using the human brain to find these anomalies.
Yeah.
So
exactly.
This is okay. So you're taking us down a good path here. I like signals. So defining the signals / the data that you require, realizing that data isn't necessarily all coming from your sensors. It could be they're going to be coming from someone's sensors somewhere, or it could be an external system. It could be another IoT product, by the way, right? I mean, these are all different forms of data. Then you're looking at the data structures. You're saying, well, most likely we're aggregating our data, and this is where my next question is going to come from, but we're aggregating our data in the cloud for a number of reasons. One of the strong ones being security. It's just a lot easier way of doing it. Also makes a lot of sense. Then we're applying our models. They could be analytical models. They could be cognitive models, as we spoke about earlier. But we are building, kind of bring out the hammer and the anvil, and we're hammering out some models that make a lot of sense depending on what we're trying to find for this data that we're collecting or aggregating. So my question is on this aggregation. So everyone listening to the show right now, they're thinking digital twins for sure. They're thinking, okay, how do I implement this? But getting down a little bit, I guess I define the digital twin as a federation of data, which could be the raw data and it can be contextual data. And that kind of implies that the data can live in different places. Now, you were saying more, so do you believe in centralizing this all in one data? Well, I guess we're going to say a data pool, I think. No, I guess we're going to say a data lake. What is your thoughts on the centralization versus the federation of this data?
Well, so that's a good question. I think it's more of a data lake because a data lake is an aggregation of different data technologies. And we do see virtualized data and federate it quite a bit. And back to early on our conversation, when we say aggregate, I didn't mean necessarily we pull it together into a single model. That goes back to that big solution. But we do need technologies that make it virtually aggregated. So you've got the virtualization tools and federated tools to bring it so you can process it. Now, what we do see, and this will continue to be for a while, is if you don't aggregate it into a same technology, not necessarily what I call conform from a database standpoint, but at least bring it to a consistent layer in its raw form, performance might really start be impacted in what you could do, because you're going to take your network hops going to different technologies, and you can control that a lot more and pretty cost effectively in a big data environment.
No, that makes a lot of sense. Aaron, anything you want to add to that before I move on?
No, I think Lane did a pretty good job of covering all that space.
Yeah,
and he's definitely much more of an expert in the technology side than I am.
Well, I think I like to just, go up a higher level and best practices. So just, I'm going to ask both you guys the same question, but so we have our listeners, they're agreeing, digital twin, super important from an Aaron perspective. Let's just say this is how we're going to create value. From a Lane perspective, this is core competency type technology. We need to understand this. We, ourselves, this is going to become intellectual property of the company. Then they're thinking, so give us some advice, guys. You guys have been doing it. Deloitte has been actually rolling up their sleeves. If you were to give our listeners maybe your top 2 or, top 3 pieces of advice or best practices, what would they be? Just, Aaron, why don't you start?
Number one, and I think I've hinted at this, said this several times, is start with the business issue in mind. Yes. Number 2, one of the critical aspects of creating a solution that's going to be of value and use is work with the people directly that are going to be using the solution at the end of the day.
Interesting.
Making sure you're getting their feedback and they're being part of the journey going forward. Otherwise, you're going to implement a solution that they're going to look at and say, we didn't agree to this, we didn't align to this, just feels like another technology capability, and they want to go back to doing it their old way. So that is a key aspect of it as well. And Lane hinted at this, but this is so critical. The analytics and the models behind it are really what drives the value in the solution when you're thinking about integrating and helping them understand where they need to focus their time and effort, what is the problem they need to address. But the visualization is what sells the solution and makes it real to the, because that is the interface of the entire thing for the supervisor or the manager or the worker on the floor, is that visual. That's their interface to the entire solution. If that's not right, if that doesn't work for them, it becomes very difficult for them to see the value or even be able to use it.
I like that. And so just to be clear, visualization is, one form of analytics that we can use to generally look in the past and try to figure out what happened and whether we're looking for anomalies or patterns or whatever the case may be. Here, you're using it in a little bit more general form, and the visualization is also the user experience to a certain extent. Am I getting that correct, Aaron?
Yeah. Correct. Yes, that is. Exactly. We look at that as the user experience, this user interface.
Yeah. Okay. No. Now that makes a little bit more sense to me. And it's the sizzle, right? There's a lot of stuff. You've got Lane back there sweating away with all the steam engines trying to crank this stuff out. But obviously, there's a lot going on, but it's hard to understand. So yeah, no, those are very good. Very good suggestions, very good tips. Lane, what do you have to add to that?
So he covered the front end. What I would say, and this is the biggest caveat, and this is not a plug for us in general, but this is a very complicated environment. The technologies are moving very, very rapidly. And we often see companies go at it thinking they've got a good grasp of all these technologies and how they can bring it together. And more often than that fails. So you really need to treat it with the respect that it deserves. You got, hundreds of vendors in this space, and you're going to need help. And if you're really serious, it's going to be very hard for a company whose job is to create motors or planes or cars to have this focus on the general market. Because otherwise you end up getting lost and just trying to figure out what the best technology is. And what we often see is people falling in love with the technology, what I would call, the next shiny piece of software, and actually what they're trying to do, especially in our technology departments that we deal with.
No, I wholeheartedly agree. It's cutting edge, right? It's not commoditized. It's the opposite. And so I wholeheartedly agree. Unless you have this intellectual, capability within and skill sets within your organization, and many companies that are embracing IoT do not, But unless you do, then this is super important. This is critical. This is what creates value. It's what I think is the most important technology. And so the return on investment for some advice and some consultation on this issue, at least from my perspective, is well worth it. And I think that's a great last piece of advice. Gentlemen, why I got in contact with you in the first place is because I read your excellent white paper on the digital twin. So I will be putting that in the show analysis notes. But where can our listeners find out more about you guys and Deloitte Consulting with respect to IoT?
So you can find that on, there's a Deloitte, Deloitte.com, and then we have our DU Publishing. So we publish a lot of articles from the DU Press. And we also have our Wall Street Journal CIO publications. And generally you can search among that, and we'll also provide you some links to link into after this podcast.
Excellent. Aaron, any other ideas? Anything else you want to put forth?
No, I think Lane pretty much covered it all, where you can find out about us and also about finding all the different articles we publish, and specifically our article on the digital twin.
Excellent. All right, gentlemen. Well, thank you for the informative discussion. You are my brothers. We think about this the same way. Everyone listening knows what I mean. So, yeah, I appreciate the points of view, and hopefully we'll be talking soon.
Thank you.
With you today.
Very nice talking to you.
Okay, that was a solid talk with Lane Warshaw and Aaron Parrott of Deloitte. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Strategy and Digital Transformation Lesson for the IoT Professional by me. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be a paired one.
You have been listening to the IoT Inc. Business Show.